Greetings once more. Welcome to Fostering Mathematics with Sir Foster. In today's video, we'll be doing the following questions. Let's check our first question. It's a hyperbola. They are saying write down the equation of asymptote of f. We know that when we are referring to equations of asymptote, this is where the function is not defined. So for this function to be not defined, number one, the denominator must be equals to 0. So this must be equals to 0. So x minus 2 must be equals to 0, meaning the x asymptote is x is equals to 2. Then another asymptote is y is equals to 3. Then we get the 2 marks. One mark x is equals to 2, the other mark x is equals to 3. Then the next one says calculate the x and y intercepts of f. We know that to find the x-intercept, this is where y is equals to 0. So from the function where we see y, we replace y with 0, 8 over x minus 2. Then we're going to try to make x the subject of the formula. Take 3 to the other side, then x minus 2. Then this is divisible by 1. Can cross multiply. Then we are going to have 3x. 3 times negative 2 is positive 6. Then is equals to 8. Then let's try to make x the subject of the formula. Negative 3x is equals to 8 minus 6 is 2. Then the value of x is 2, negative 2 over 3. This is the x-intercept. Then let's go for the y-intercept. Y cut y-intercept this is where the value of x is equals to 0. Here is x, more than x, we get 0. Then we're going to have 8 divided by negative 2 is negative 4, negative 4 plus 3. Negative 4 plus 3 is negative 1. Then this is the x-intercept and the y-intercept. So if they say I must write down the coordinates here is negative 3 over 2 and 0. The coordinate here is 0 and negative 1. So let's mark. We need to give it 3 marks. 1 mark, then 2, then this is 3 marks. The next one says we must sketch this hyperbola. When we sketch in a hyperbolic graph, we must take note of the following. If the value of a is greater than 0, in our case, value of a is 8 is greater than 0, it means that we are going to have a hyperbola that is decreasing. So if this is the y asymptote, then if this is the x asymptote, then the graph is going to decrease from the left hand side. That is the value of A. We also know that the value of P and Q, we need to find the value of P and Q, the X and Y asymptote. Then we need to find the X and Y intercept. X and Y intercepts. So we have X and Y intercepts, we have the asymptote, we can sketch the graph. So let's start with the X asymptote. X asymptote is 2, the Y asymptote is 3. So X asymptote 1, 2. This is 1, this is 2. So this is our X asymptote. So here the graph is not going to be defined. Then the Y asymptote is 1, 2, 3. Then remember hyperbola, we're having twins in hyperbola. So let's check the x-intercept. We're having 2 divided by 3, negative 2 divided by 3, which is approximately 0, negative 0, comma 6, 6, 7. So here we're having negative 1, then negative comma 5. Somewhere there, here is our x-intercept. Then the y-intercept is negative 1, here is our negative 1. Then we must make sure that the graph does not intersect with the asymptote. So I have to join these 2 points. Let's join them. Then it must be a curve. Then the side. Then if the other twin is this side, the other one must be that side. Therefore, this is the sketch of f at x. This is the sketch of f at x. Then they said we must, let's check the question. Sketch the graph of f, show clearly the intercepts with the axis and the asymptote. Let's show them. So we're having the y asymptote, y is equals to 3. We're having the x asymptote, this is x is equals to 2. Then this is the coordinate where they meet. X is 2, then 3. Then here we're having negative 2 over 3 with a 0. Then there we're having 0 and negative 1. Then let's mark. So how many marks? 3 marks. So let's mark 1 mark for the intercepts, both x and y intercepts. Then 1 mark is for the asymptote. Then 1 mark is the shape of the graph. Then it's 3 marks. The next question says Next question. I'll check a question on Latana. The next question says, if y is equals to x plus k is an equation of the line of symmetry of f. Calculate the value of k. Remember, we are having a line of symmetry. In hyperbola, we having the one with the positive gradient, which is defined by this equation. We also having the one with the negative gradient, which is defined by this equation. Then all those lines they pass through the asymptote, meaning we must use these coordinates. So I can also use that method, but we are told that the equation of this line is y is equals to x plus k. Then I can use the coordinate. Remember, the equation of axis of symmetry must pass through the asymptotes. So the x asymptote is 2, the y asymptote is 3. So from this equation where I see x, I'm going to replace it with 2, where I see y, I replace it with 3. So 3 is equals to 2 plus k. Then I make k the subject of the formula. K is equals to 1. Then you get your 3 marks. Or I can also use this approach, equation of axis of symmetry with the positive gradient. I come from the equation. I draw my very nice car. Yes, this is my very nice car. From this, I can write down the equation. Equation of axis of symmetry with a positive gradient. From the equation, I draw a very nice car. Yes. Then from there, I'm going to write y. F at x represent y. Y is equals to, what are we having? X. Y is equals to x minus 2 plus 3. Then if I simplify this, I'm going to have y is equals to x. This one plus this one is 1. Then what is the value of k? The value of k is a constant. Therefore, this is the value of k. Therefore, the value of k is equals to 1. Then we are also told this other information, the graph of f, question 4.5. The graph of f is reflected about the x-axis to obtain the graph of g. Let's talk about the reflection. When we are talking about the reflection here, we can think about the mirror. So we are having a reflection about the x-axis. So let's talk about the reflection. So reflection about the x-axis. Reflection about the x-axis. If I'm having the coordinates x and y, if I reflect these coordinates about the x-axis, x must remain the same, then y is the negative inverse. So y is multiplied by negative. So meaning reflection about the x-axis, x remains the same, y is the negative inverse. So the reflection about the y-axis, the opposite here, if I'm having coordinate x and y, if I reflect them about the y-axis, then y will remain the same, then x is the negative inverse. So this can also apply to functions. We are saying we need to reflect f. F is reflected about the x-axis to obtain the graph of g. Write down the equation of g. So we must have the equation of f first. Let's write the equation of f. 4.5. Remember, f at x is equals to 8 over x minus 2 plus 3. So from this equation, we are just going to write it in the form of y because I need to reflect it about the x-axis. Reflection about the x-axis, yes. Remember, reflection about the x-axis, x must remain the same. So let's reflect this about the x-axis. So this is y. We're going to multiply it by negative. Then reflection about the x-axis, x remains the same. We have applied this rule. Reflection about the x-axis, if I'm having x and y, then x will remain the same, then y is the negative inverse. So the same thing we apply it to this function where we see x, we do nothing to x, then we are going to multiply y by negative. Then we need to make y the subject of the formula. Y is equals to, we divide by negative, then what is the equation? Therefore, the equation of g at x is equals to negative 8 over x minus 2 minus 3. This is the equation of g at x, which is the reflection about the reflection of f about the x-axis. Write down the domain of f. Remember, when we are talking about domain, we are referring to the values of x where the function is defined. If you can check this function, if I can move my ruler. Okay. If I am moving vertically from the left to the right, looking at the values of x, this function is defined from negative infinity to positive infinity. Then the only place where this function is not defined is when x is equals to 2. So it means that when we write the domain of this graph, we are simply going to write x is an element of real numbers, meaning this function is defined throughout from negative infinity to positive infinity. But when x is equals to 2, the function is not defined. When x is equals to 2, the function is not defined. So we are writing the values of x where the function is defined. So when x is equals to 2, the function is not defined. So we need to cancel the equal sign, meaning this function is defined for all values of x, but the function is not defined when x is equals to 2. So meaning x must not be equals to 2.